In this screencast, we are going to talk about different coloring agents for glass and then different types of glass. So when we talk about coloring glass, a lot of times glass is colored by adding transition metal ions or metal oxides. Now, this is also used for coloring glazes that are in pottery or ceramics. And so we're going to talk a little bit more about how or the chemistry behind this when we get into that module. What we're going to focus on in this module are the metals that cause the different colors. So the first metal that we're going to talk about is iron salts. Now, iron has two charged states, or what's sometimes called oxidation states, iron 2+ and iron 3+. All right. And so when we look at this, we can get two different colors. We can get this color. This is iron with sulfur. And then we can also get a dark green color, and that's when it's combined with chromium. So it's iron combined with chromium. So iron can give us those different colors. Now we also have manganese. Manganese gives us a really pretty purple. Its charge is 3+, and so a lot of times the metal oxide that's added is manganese oxide, and that's the form of it. It was one of the earliest coloring components that was used by Egyptians, and this is an example of the really pretty purple that it gives us. So manganese will give us purple. Iron will give us green and kind of an amber color. So in case you printed this off not in color, there's green and amber, and then this gives us a purple. Now, copper is used as a coloring agent. It can give us kind of a turquoise blue, which you can see right there. You get cobalt. Cobalt glass is this really beautiful dark blue glass. So it gives us a dark blue, right? And that was used for stained glass in the 12th century. And then chromium gives us as either chromium oxide or potassium chromium oxide, or potassium chromate, sorry. This really pretty dark green. And if you notice, right, you can get a dark green with iron. You can also get one with chromium. Chromium tends to be a little bit more common now than iron does. Nickel gives you a really pretty smoky color. So it's like a gray smoky color. That's nickel. So it gives us a gray smoky color. Right. Gold gives us this really pretty red. A lot of times it's called ruby gold or a cranberry color. It's described as cranberry. Okay. And then uranium glass from a uranium 2+ is a yellow color like this. Now, uranium is really interesting. If it put under a black light, it'll fluoresce. Right, so, and I'll have a black light for you to see this in lab so that you can see what uranium looks like. But there's a lot of really neat images on the internet of uranium glass fluorescing. So these are our common coloring agents. This is just the basics. Again, we'll talk more about it when we get to phases. But right now we're going to talk about different glass types. So when we talk about different glass types, we are going to talk about 5 different specific glass types in this screencast. The first glass type that we're going to talk about is quartz glass. That is just fused silica. Okay. Then we're going to talk about soda lime glass, and this a lot of times is used as a window glass. We're going to talk about borosilicate glass. This a lot of times is used as scientific glass. So think test tubes. It's also really common in Pyrex. We're going to talk about leaded crystal, and then specialty glasses like transition glasses. So let's jump in and talk about quartz glass first. This is also known as fused silica, and it is pure SiO2. It's pure silica dioxide. It has a really high melting point at around 1723 degrees Celsius. It has a very high viscosity. That means it flows really slowly. It is very chemically and physically durable. Right? And what's really important is that it's transparent to visible and UV light. So we can use it for different scientific measurements where we measure light. And so this is an example of a glass cuvette, and we use glass cuvettes to measure light, and it's made out of quartz glass. These are also different crucibles that are made out of quartz glass as well. So there's many scientific applications for quartz glass, and the big reason is because it's transparent to visible and UV light. Another common type of glass is soda lime glass. This is composed of silica dioxide and sodium oxide and calcium oxide. It's used to make windows, mirrors, and bottles. In this, when you add the sodium oxide and the calcium oxide, that lowers the melting point to 1300 degrees Celsius. And the other thing that does is that this particular glass can be attacked by strong acids or bases. So this glass can be etched if you use either strong acid or base. It has a high thermal expansion. And when we talk about a high thermal expansion, remember that just means it cracks. Easily when cooled. The next type of glass we're going to talk about is borosilicate glass. Instead of, let me say this. It's still got the SiO2. It still has in the sodium oxide, but instead of calcium oxide in the soda lime glass, it now has the boron oxide. This has some brand names. So this is sold under brand names like Pyrex, which is like a cooking glass. Chemex is an older one. This, when we add that boron, it lowers the thermal expansion of the glass so it doesn't crack as easily. This is one of the reasons it can be used as beakers. So I've got some examples of Pyrex beaker there. It can also be used in cooking applications, like you have Pyrex, like brownie dishes and things like that. And so it's got a lower thermal expansion of glass. So when you heat it and cool it, it's not going to crack as easily as your soda lime glass would. It also has a little bit lower melting point and viscosity. It's very durable, it's chemical resistant, and it's used in scientific glassware and household cookware. Another type of glass you'll hear about is leaded crystal. That's a misnomer. It's really leaded glass. Right? It's just cut to look like crystal. It's made out of silica dioxide, sodium oxide, potassium oxide, and lead oxide. So it's got 4 different components right there in it. It's got a lower melting point and viscosity than what we've seen before. It's also a highly reflective and refractive glass. So it has a lower melting point and viscosity. It's highly refractive and reflective, and that's why it looks really pretty. The problem with the lead is that it can be poisonous in glass and unfired pottery. Right? Particularly because it can be leached by acids. And there's a lot of things that are really acidic, including our water is slightly acidic. Now, leaded glass does have a really great application. It's used to shield from radiation. The next type of glass that we're going to talk about are specialty glasses, specifically the transition lenses. So transition lenses are ones that are, when you're indoors, they look like regular glasses, and then you walk outdoors, they transition to sunglasses. These were invented in the mid 1960s by Corning Glass. And the way this works is it contains 0.01 to 0.1% silver chloride and copper chloride. Now, what happens is the UV light decomposes the silver chloride to produce the silver atoms. And when that happens, the glass darkens. Right? Now, this is similar to photography film. Then, in the dark, right, or when you come inside, right, when it's darker, when it's not outside, the reaction is reversed by the copper in the glass. Right? And so that's how those transition glasses work. Other specialty glass are things that you'll see as iridescence on glass. You get this when you have multiple layers of glass. And there's a couple ways this can happen. This can be produced through weathering, and corrosion. I feel like I put too many S's in corrosion, so pretend like I spelled it right. And this weathering and corrosion, the reason it gives the iridescence, which is the shiny colors that you see here and here, right? So these are the different glass samples that I have for you. It causes refraction of the light, and the production of interference colors. So this is a flashback there to our light chapter where we talked about interference and refraction and reflection. And so you can see this in kind of ancient glass, which is shown here, and then in more modern glass as well. Other uses of glassy materials. So there are two big uses of glassy materials that we're also going to talk about. One are enamels. Enamels are just thin layers of colored glass that are applied to the surface of the metals. Then we can also have glazes. We're going to talk about glazes more when we get to our ceramic chapter as well. But these are just layers of colored glass. Melted onto the surface of pottery and ceramics. So let's look at some of the materials that are used to make glazes and enamels. This is a common glaze. You can see it's turquoise matte. This is a ceramic piece, and it's got this turquoise color that's glassy on the top. You'll notice that it's got the nepheline syenite that we talked about before, strontium carbonate, ball clay, which we have not talked about, but we're going to, flint, lithium carbonate, and copper carbonate. And that's where we're getting that color from, that turquoise color. So these are different components that go in to make a glaze. And so every artist kind of has their own recipe for glazes that they can put on their pottery. Enamels are made of different types of materials, but when it comes down to it, a lot of them are silicon dioxide and sodium oxide. So the British Museum did a study of enamels, and they looked at medieval enamel glass versus Roman enamel glass. And what they found is they pretty much had all the same ingredients: silicon dioxide, sodium oxide, calcium oxide, potassium oxide, and magnesium oxide. And this is pretty impressive that all of these were that close between these two time periods for enamels. So applications of glaze and enamel. Glazes, and by application I mean how are they applied, right? Not what is the application of these. We've already talked about that. They're on pottery and things of that nature. So glazes are generally applied as slurries or suspensions. Right? And they can be applied by dipping. So you might dip the piece in a glaze. You might spray the glaze on a piece, or maybe you paint it on. Right? Now, here is the big deal about glazes and enamel, is that it must match the thermal expansion and contraction characteristics to whatever it's being applied to. So to those of the clay body or that metal surface. So remember, if it's a metal surface, that's an enamel, right? And if it's applied to a clay body, then that's called the glaze. All right, this ends our glass module, and we will then pick up with ceramics.